All right, well, good morning, class. Sorry I'm not here today, so you get a chance to listen to me via a video. So 3.6, we have one last thing to do with quadratics, and that is another way that we can solve for x is by using what we call the quadratic formula. So our hope today and our goal today is that you're going to be able to solve these equations by using the quadratic formula. Also, we'll talk about a key piece of it called the discriminant and use the discriminant to figure out the number and type of roots for a quadratic equation. So, if we take a look here in the vocabulary, this is what we basically have been doing in all of Chapter 3. We have found the solutions by graphing. That was like in 3.1 and 3.2. Sorry about the bell. We've also been doing them by factoring. That was 3.4. Okay? Yesterday, we did it by completing the square, 3.5. You might be saying, well, what about 3.3? 3.3 was all the imaginary, so some of our solutions could be those imaginary numbers. So we can solve any quadratic equation by using the following formula. Here's the formula. And the formula simply goes x equals, and if you know the song Pop Goes the Weasel, this might be the first time I actually sing to you, it goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the a, b, and c values are the a, b, and c values that we've been dealing with all throughout this unit where it's in standard form, ax squared plus bx plus c. So you might have to manipulate this. So you can see in this example right here, you can see that a is 1, okay? B is 5, so I do the opposite of 5, and then 5 squared here. Minus 4ac, 4, the a is 1, the c is 6. So it's plugging in these values and then just mathematically simplifying that expression. So let's take you through some examples. So you'll see how we give you examples where you're going to get different number of solutions. So we can get what we call two rational roots. Basically, your answer is going to be a number or a fraction. So the first thing I actually have to do on this one is get it equal to 0. So of course, we like to throw you for a little bit of a loop right off the bat. So I got to make sure that I move that 33 over to the other side. So now I'm just plugging it into the quadratic formula. X equals the opposite of b. So the opposite of negative 8 is positive 8. Plus or minus the square root of negative 8 squared minus 4 times my a value here is 1 times my c value, which is negative 33. All over 2 times 1. So now I just start to simplify. I get 8 plus or minus negative 8 being squared. I'm hoping you could actually do that in your head and get 64. If I take negative 4 times 1 times negative 33, two negatives actually make it be a positive, adds to 132. So 64 and 132 make 196. All over 2 times 1 is 2. So now I need to take the square root of 196. That's actually a perfect square. So if you don't remember that it's 14, you just come over to your calculator, go square root of 196, and I get 14. All over 2. Well, 2 goes into both of these, or what you can do is say, all right, 8 plus 14 divided by 2, well, that's 22 divided by 2, which is 11. And then 8 minus 14 divided by 2, negative 6 over 2 equals negative 3. So I have my solutions, x equals 3 or x equals 11. And I get two solutions. All right, what I would suggest doing right now is just pausing the video and try this example right here where you move the 30 over to the other side to make it negative 30. I'm going to do it here quickly, but I pause, do it, and then listen to me go through it quickly. All right, so here I go through it quickly here. So x equals negative 13 plus or minus the square root. 13 squared minus 4 times 1 times negative 30 all over 2 times the a value, which is 1. So x equals negative 13 plus or minus the square root of 13 squared, 169, minus a minus makes a plus. So if I add negative 4 times 1 times negative 30, makes 120. Add those together, I get 289 all over 2. Well, the square root of 289, I believe, is 17. Let me hit enter there. There it is, 17. So x equals negative 13 plus or minus 17 all over 2. So x equals negative 13 plus 17 divided by 2, which is 4 over 2, which is just 2. So that's one solution. Negative 13 minus 17 divided by 2, that's negative 30 over 2, and that's equal to negative 15. All right, so that takes care of the first examples. You get 2 rational roots. The next example, you can get 1 rational root. It's just doing the same thing, plugging it in and simplifying, and what you're going to see here is the plus minus piece of your quadratic formula, this piece right here, is going to disappear. So watch what happens here when I do this one. So x equals negative b. So b is negative 34, so it becomes positive 34. Plus or minus the square root of negative 34 squared minus 4 times 1 times 289. Wow. All over 2 times 1. So over here on my calculator, in parentheses, negative 34 squared. Okay? In fact, what I can do is I can go minus 4 times 1 times 289. So long as I follow my signs, they'll tell me that that actually equals 0. Well, so basically what I'm getting here is 34 plus or minus the square root of 0 over 2. Well, the square root of 0 is just 0. So this part crosses out. So I'm just left with 34 divided by 2, which is just 17. All right, pause the video for a second and try the second example there. All right, so as I'm doing this one, I get x equals positive 22 plus or minus negative 22 squared minus 4 times 1 times 121 all over 2 times 1. Well, negative 22 squared is 484 minus 484, so that ends up being 0, just like the other one. So I have 22 plus or minus the square root of 0 over 2. That crosses out. 22 divided by 2 is just 11. So you can see that on that one, I'm only getting one solution. All right, let's go to the next page. So sometimes you'll get what's called irrational roots. Irrational, basically, what this means is your answer will have a square root in it. Okay? So let's take a look at this one here. So I get x equals, the opposite of negative 6 is plus 6, plus or minus the square root of negative 6 squared minus 4 times 1, okay, times 2, all over 2 times 1. So now, I'm going to simplify the radical here. Negative 6 squared is 36, minus 4 times 1 times 2 is 8. So now, right now, I have x equals 6 plus or minus the square root of 28 all over 2. Notice how 28 is not a perfect square. However, I could rewrite that as a perfect square, which is 4 times 7. So I look at factors where 1's a perfect square. So what I'm doing is I'm starting to simplify. So I get x equals 6 plus or minus the square root of 28 is like saying 2 square roots of 7, all divided by 2. Now you might be asking, why in the world would you do that? Sorry about the bells. Well, the reason why you do that is because now I can actually simplify and I no longer have a fraction. 2 goes into both of these, so I can simplify this as 2 goes into 6 3 times, 2 goes into 2 once, so I have 3 plus or minus the square root of 7. Notice how my answers are irrational because I have a square root as a final answer. All right, pause the video, try 3B. All right, coming back to 3B here, I have x, so I'm just plugging it in the formula. You can see how this just keep plugging and chugging. Negative 5 squared minus 4 times 1 times 3 all over 2 times 1. So I get x equals 5 plus or minus 5, negative 5 squared is 25, 4 times 1 times 3 is 12, 25 minus 12 is 13, all over 2. These are ones that students actually really like because square root of 13 doesn't have a perfect square in it. It's actually a prime number. We're done. So we get some answers that even look that funky. All right, last one's complex roots. So on these two examples, when we do it, you might get a square root that's negative and have to simplify that. So let's take a look at this one. So first of all, it's not in order. So I got to rewrite it. X squared minus 6x plus 13 equals 0. So I move that 6x over by subtracting it. So now I can start to simplify. X equals positive 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13 all over 2 times 1. So now as I simplify this, x equals 6 plus or minus, I get 36 minus 52, which is negative 16, all over 2. So now if I think about the square root of negative 16, that's like saying the square root of 16 and the square root of negative 1. So that tells me now I have x equals 6 plus or minus 4, square root of 16 is 4, I all over 2. So just like I did in the previous one, they're all divisible by 2. So when I divide them both by 2, I'm left with 3 plus or minus 2i. I have an imaginary solution. All right, pause the video and try example 4b. All right, as you come back here, we have x squared. I got to move that 4x to the other side, so I have to subtract it. But I'm doing the same thing that I've been doing. X equals positive 4 plus or minus the square root. Negative 4 squared minus 4 times 1 times 5 all over 2 times 1. So as I start to simplify this, x equals 4 plus or minus 16 minus 20. 16 minus 20 is negative 4 all over 2. So now, the square root of negative 4 is square root of 4, square root of negative 1. So now, this simplifies to x equals 4 plus or minus 2i all over 2. I can reduce them all by 2, so I get 2 plus or minus I. Awesome. So we did 2 examples using the quadratic formula here, where we got two real solutions, or 2 rational solutions, 1 rational solution, 2 irrational solutions, and 2 complex solutions. So this leads to the next set of notes here. And that's how we can actually identify how many solutions, and that's all dependent on what we call the discriminant. So the discriminant is this b squared minus 4ac. It's the part under the square root. Because what you notice is that, hey, if this ends up being a nice perfect square, okay, or a positive, number that's a perfect square, okay, you get, as it says here, that's a perfect square, you get 2 real rational roots. If it's positive, but not a perfect square, then you can't simplify the radical, and you get 2 irrational roots. When it equaled 0, when you took the square root of 0, it canceled out. That's where we were getting 1 real root. And when it was negative, so when it's less than 0, this is like saying it's negative. Square root of a negative number gives you your complex root. So hopefully you're noticing the patterns there. So the value of the discriminant can be used to determine the number and type of roots in your quadratic equation. So how we can use that here is we have some examples here at the bottom. So it says find the value of just the discriminant for each equation and then describe the number type of roots that you have. So like on this first one, here my b is negative 11. So I'm going negative 11 squared minus 4. My a value is 1. My c value is 10. So when I simplify this, 121 minus 40 ends up being 81. It's a positive answer, and it's a perfect square, so I have 2 real rational roots. So we do the same thing for the next one. B squared, so I'm going 8 squared minus 4 times 1 times 16. 8 squared is 64, minus 4 times 1 times 16 is also 64. That gives me 0. So if I look back up here, hey, when that discriminant equals 0, I get 1 real rational root, or roots. In this case, it's just a root. Looking at the last example, okay? So b squared, so negative 2 squared minus 4 times 1 times 7. So I get 4 minus 28. Wow, I get negative 24. So in this case, since it's negative, I get 2 complex roots. All right. So if you just flip to the last page, this last page is very nice in your notes, mainly because it tells you how the different ways that we talked about in Chapter 3 that we can solve, okay, and when we use it, okay. So graphing, it can be used sometimes, but this is really only good if you're looking for an exact answer. Great to use to kind of check your work to see if your algebraic solutions are nice. Factoring works once in a while. So that's where we're doing greatest common factor and stuff. Sometimes factoring isn't the greatest. Square root property, okay? That's like when we can have it as a quantity squared, okay? We can solve, that can be done sometimes. But the last 2 days, completing the square quadratic formula, always work. Doesn't matter how complex it is, we can do the algebra and solve them both ways. All right, so take the time now after watching this video and take out the worksheet that was handed out to you yesterday and work on the problems on the back side of that worksheet. It'll say worksheet 3.6. There's a total of 6 problems there. The key is on the Moodle site. Thank you very much. Hope you enjoy the rest of your Friday.